in this video, I'll start by explaining how this tachometer works, and from sensing RPM to how the STM32 processes the data, and how ESP32 sends the data from here to web dashboard here. And in the next clip, I'll show the complete output, as you can see the live RPM measurements in action. And stay till the end to understand the full integration, the data flow, and how everything comes together to deliver real-time RPM tracking. I'll be explaining in detail how each component in this tachometer works. So firstly, I'm using the 9-volt battery as the primary power source. So since the microcontroller which is STM32 needs a stable 5-volt supply, there's also a voltage regulator that I've included here, which converts 9-volt to 5-volt here. Okay, so which makes sure that there's voltage down safely and to protect the circuit from overload. And so here the STM32 is the main processing unit. It reads the sensor signals and calculates the RPM. To detect the rotation, I'm using this the IR sensor. So every time the tape with the fan, okay, the fan has a tape. So every time the tape passes, it generates a pulse, and the STM32 uses the pulses to compute the RPM accurately. And there's also, we have used ESP32 here, which handles the IoT communication after the STM32 calculates the RPM. This ESP32 receives the data and uploads to the web, okay? And so the RPM can be monitored from live from anywhere, like from anywhere you can monitor the RPM. So I've also used the supporting components like capacitors and for signal stability, and operational amplifiers for the conditioning the sensor output. And of course there needs to be a lot of jumper wires to connect all this stuffs together and put it together. And of course there's also a breadboard connecting all these things together. These components manage power regulation, sensing, as well as wireless data transmission, forming complete IoT-based tachometer system. Now that we have seen how the hardware works, now we've also designed a clean and user-friendly website to display the real-time tachometer. And in the next clip, my friend will explain how the data from this tachometer is transferred from web, and how the values are processed on the dashboard, so that you can understand how basically this web dashboard is working.
Hello guys, this is a website for a tachometer. This is where the customer would see the RPM values of lively. Now let me go to the website and the customer point of view, and I'll also explain how the website is made by side. Whenever a customer receives a product, they'll be given a QR code and also a specific device ID for that tachometer they have had it. When the customer scans this QR code, that would automatically lead them to this website. Now let us enter to the website. We plan to build a product based project for our this semester. So what we planned out was we build a landing page for our website explaining what our product is about and how it works, and also giving the users the feel of using a product. Like a demo view is also available in this landing page. Let me go through that. So this is a landing page. This is what it is like. This explains what is the tachometer and how it works, why it is useful, and this is what the steps required to use our product, how it works section explains that. Your data, your dashboard section explains the demo of how the website is inside after the user buy a product. This is in this way they'd be viewing their RPM data. This is just a sample data. So founders obviously is our teammates. So let me go through the website. This is the landing page now. Let me get started. As I mentioned earlier, each customer would be receiving a specific device ID according to their tachometer. So this is our ID which we use for trial purposes. So let's go to that. Now this is the basic view where the customers would be seeing after entering the device ID. This live gauge shows the RPM data. Like we have this live gauges in our motorbikes, scooties, everything. So it works in a similar way but digital. Now this RPM data, live RPM, shows the very graph and like to make the visuals much better. We planned out with this. This live RPM shows the current RPM, the same value as this, and here the session RPM shows the overall average RPM of the session, which is auto updated. Here the session max RPM is like as the name suggests, it is the max RPM of that particular session. So this RPM distribution actually shows a bar graph session history here where we can compare our sessions, so 2 to 3 sessions. Our product is designed in such a way that we can measure RPM for any rotating object, so whether a small table fan or even a ceiling fan or bike wheels, so we can compare the RPM using that. This is also visible here. So now we'll start the device. Now what happens is once we start the device here, we should also switch on the power button in our tachometer. So if that is on, we can, from there, what happens is our ESP32 sends the data sent by STM32, which measures the RPM and sends it to the cloud through ESP32. From our cloud, the job of the website is to pull the data from the cloud and display it here neatly, and it presents well. I'll explain the process of the cloud thing later. Now let me just start the website, and now the device is not switched on actually. So we will be receiving only the latest data, like the last data what the RPM was measured. So yeah, 850 is the latest data with what is measured. So when the tachometer is switched on, we can receive the live data. So this is live RPM, this is session RPM and maximum RPM what we recorded. So this data comes from the previous sessions where this was the data was showed in the cloud. Now this is what it is. So see here the device is switched on. In our database too, it is switched on, which is true means it is switched on. If it is switched off, here it is switched, it's false. So what I'm trying to say here it is completely live and nothing is demo or spam data. So now yeah, this is what the customer point of view is done. The customer's point of view is done with this website. Now let me explain how this was made and all. So this website was completely made with TypeScript. So TypeScript and React components was completely used. This is also a particular live component which inspired us from Galaxy stuff. So we thought we could include this here. This landing page has also like few great animations, I guess. So this was inspired from a product what we saw. So we thought that would be cool to add here. And this neon effect was also inspired. We made the live design of this. We did the 3D modeling for this particular logo, and we made this movement of the tachometer text is also animated, and it is also a React component. Yeah, so this is basically a React component. So I'll go to the VS Studio's code here. So as you can see, there are many panels, like there are many sections for our website, right? So this is a section, this is a hero section, this is the landing page section, this tell how it works, this is a demo page. So for that, we'll be having separate components and separate lists. So here, see, we use the sample data. We can also for at the starting before using our ESP32 for checking the working of cloud. What we did was we used this sample.json to test our data. Now we'll go to the conference side. So yeah, this is what it is. So everything here was coded. Now what we did next, how it works is, so our ESP32, right? But what job it does is it takes the data from ESP32, it sends it to the cloud. So cloud, what is cloud? I'm just mentioning cloud, right? So this is what cloud is. We are using Firebase as our cloud. So cloud is a real-time database where data is fetched directly to from here to our app. So at the starting, I mentioned that every device here has a unique ID like that, right? So this is what it is. When we deliver a product to a customer, we can add the specific device ID. So let me make a trial run here. So this is what I sorry. Here we can add the tachometer's name and we can give them the required value we want. So here, so there are two components here. So data components is the what the live data is which we fetch from the specific uh, tachometer, which the ESP32 sends actually. Is on is the data where, like, if it is on, if the website decides to pull the data, it should be on, or else it can be off, switched off. So real-time database here, we use this Firebase, and we use the TypeScript here. So we'll be also giving the products VS Code GitHub repo in the description of the video. And this is it. Any comments, any doubts can be given in the comment section.
So now that you have seen how the entire website works and how the RPM is displayed, I hope the whole system makes sense now, and from the hardware to the final output. And so yeah, thank you so much for watching and staying till the end. Thank you.